Welcome friends to my YouTube channel. Now, yesterday's lecture I had told about the equation of motion of a particle in a central force field, and there I discuss two equations of motion. One is radial equation of motion and another is cross radial equation of motion. Okay, the radial equation of motion looks like this: m into r double dot minus r theta dot square, this equals to f of r. This say 1, and the cross radial equation of motion yield the result mr square theta dot equals to L, angular momentum. Okay, now I also told that these two equations are generally known as integrals of motion, right? Now, as I told earlier, that in case of a central force field, the total energy of a particle or an object remains constant. We also yield at the same result by using these two equations. It can also be shown by using these two integrals of motion, and today at first I shall do it. Okay, so how we can justify it? The total energy by using this equation. Okay, so just simply write the equation 1, that is mr double dot minus mr theta dot square equals to minus del v del r, right? So mr double dot minus mr, just from here we write theta dot equal to L by mr square, so L by mr square whole square plus this is del v del r equal to 0. This is simply mr double dot minus L square by mr cube plus del v del r equal to 0. Okay, this is simply mr double dot plus del del r of L square by 2mr square plus del v del r equal to 0. Del del r of L square by 2mr square means minus L square by mr cube. That's why I write this in terms of this. Now multiply this equation by r dot. So this is simply r dot r double dot. R dot means del r del t, so this becomes del del t of L square by 2mr square, and this becomes del v del t. Okay, now this term can be written in terms of derivative t, this del del t of half mr dot square. Okay, plus this is simply del del t of L square by 2mr square plus del v del t, this equals to 0. Okay, so simply this. Now if we add, if we do one more step, then what would be the result? So I can also write d dt if I take once. So d dt of half mr dot square plus L square by 2mr square plus v, this equals to 0. Okay, so this term within the bracket is constant. mr dot square plus L square by 2mr square plus v, this is constant. Okay, so what does this term represent? This term is nothing but the total energy, because this is kinetic energy and this is potential energy. So the potential energy consists of two terms. This term L square by 2mr square is known as centrifugal potential energy. Centrifugal potential energy, and this V is known as ordinary potential energy. Ordinary potential energy. Okay, যে half mr dot square represents the kinetic energy, and these two terms is known as potential energy, and there are two parts. V is ordinary or normal potential, and L square by 2mr square is known as centrifugal potential energy. Thus we have arrived at the result. Okay, So this is the case. So we arrive at the energy conservation by using radial and cross radial equation of motion. Okay, now our next task is the Kepler's law of planetary motion. Kepler's law of planetary motion. Now Kepler gave three laws based on the central force planetary motion, which are very famous laws. Okay, that is, we can explain the motion of planets and satellites by using these laws. Okay, so first law is what? First law represents that each planet revolves around the sun in an elliptical orbit with the sun at one of its focus or foci. Okay, so elliptical orbit, you all know that this represents the major axis and this minor axis, and there are two foci. Say this is one. Okay, here the sun is located and there is the planet. So there are two coordinates. This is azimuthal angle theta and this is the radial distance r. Suppose this is one foci and the sun is located at this foci, and at any instant the planet is here. So the motion will be described by two coordinates. So a radial distance r and the azimuthal angle theta. So there are two coordinates involved here. Okay, so this is the first law. So one thing must remember that when the focus we take here, this is the maximum distance r max and this is r min. But if you take the focus here, then this is r max, this is r min. Okay, when you take this is the r max and this is r min, and when you take this is r max, this is r minimum. Epihelion, perihelion, I will discuss it later. So what does the first law states? That each planet revolves around the sun in an elliptical orbit with the sun at one of its foci. Okay, that means since there is a elliptical shape orbit, so the orbit must have a conic section equation through which the motion can be represented. Okay, so for each figure, say whether is ellipse say, or parabola or hyperbola, there must be a corresponding conic section equation. So at first we have to find out that equation. Okay, so how we can explain it mathematically? Okay, so let's do that. Okay, so how we can explain the first law, that is the conic section equation or introduction of elliptical orbits. So let's proceed. So what I tell, that total energy of a particle in a central force field remains constant. So we can write this as I proved earlier. Okay, so little bit of simplifying, we get half mr dot square, this equals to E minus V minus L square by 2mr square. So what will be my r dot square? This is simply 2 by m E minus V minus L square by 2mr square. And what is my r? This is simply square root of this term. So 2 by m, and V is nothing but minus k by r. So potential energy minus k by r. Okay, so this is simply plus k by r minus L square by 2mr square. So this gives equation number 1. So we can get r dot in terms of this. And again, we all know that angular momentum remains conserved, that is mr square theta dot. So what will be my theta dot? L by mr square. Now if we divide these two equations, then what we get? If we divide these two equations, then what we get? If we divide these two equations, then we get d theta dr. This is simply L by mr square 1 by root over 2 by m into e plus k by r minus L square by 2mr square, right? So what will be my d theta? Simply this is L into dr by mr square root of 2 by m into e plus k by r minus L square by 2mr square. This. Now we have to do a slight conversion of variable. That means how? So just let's take r equal to 1 by u, where u is a variable that we choose in such a way that r equal to 1 by u. You always have to take r in this format. Okay, so what will be my dr? Minus 1 upon u square du. So if we substitute the value, then what you get? U in terms of u. Now you have to convert r in terms of u. So there will be a minus L, and there is r square means 1 by u square, and this is u square cancel. So L du by m square root 2 upon m, 1 by r means u, so ku minus L square u square by 2m. Alright, no problem. So we have to do a slight calculation. So that will be minus L into du by square root of, if you take it inside and multiply, then what we get? 2me 2mku minus L square u square. You get this. Okay, if we simplify, we get it. Now if we divided both sides by L, then what we get? If it goes inside the root over, it becomes L square. So 2me by L square plus 2mku by L square minus u square. Okay, now one thing we have to do, that we have to rearrange this term in terms of this format, that is something square minus something square. Okay, here one thing we have to do, that we have to rearrange this term in this way: something square root something square minus something square. Okay, so if we take it this, then it would become this. You just check. This can be written in this way: square root of something square minus something square. Okay, why? Because we have to integrate this. Okay, now if you integrate this, now this becomes this formula. We have to make it in terms of this. We have to rearrange in this way that the formula becomes this. So this is dx by root a square minus x square. If you take it, or if you integrate it, integrating, so this is simply theta, and this is what? Integration dx by root a square minus x square means sine inverse x by a, and since there is a minus sign, so what will be the formula of minus? Cos inverse x by a. Okay, you all know it, that integration dx by square root of a square minus x square is the direct formula of sine inverse x by a. And if there is a minus sign before, the formula becomes cos inverse x by a. And since there is a minus sign, so you can write cos inverse x is what, this u minus mk by l square, and this is simply square root of 2me by l square plus m square k square by l to the power 4. Okay, so we can write in this way. Now if we simplify it, what we get? If we simplify it, we get u minus mk by l square. This is equal to square root of 2me by l square plus m square k square by l to the power 4 cos theta. So what will be my u? My u will be mk upon l square plus this 2me by l square plus m square k square by l to the power 4 cosine theta. So if you take mk by l square common, so it will be 1 plus l square by mk and this. So 2me by l square plus m square k square by l to the power 4 cos theta. Okay, so simply mk by l square, if you take it inside, then it would become 1 plus 2el square by mk square. You just do it. Okay, if we take it inside, this time this. Now what is my u? We take r equal to 1 upon u, so my u will be 1 by r, and this we take small l, this is 1, this is epsilon cos theta. Okay, so we arrived at the standard form of conic section equation. Okay, elliptic, we arrive at standard conic section equation. Okay, so that's why I do lot of mathematics to show this, that we can ultimately reach at conic section equation. Okay, provided what we assume, that I write here, what we assume here. Okay, since we are considering elliptical orbits. Okay, elliptical orbit, we all know that the equation of ellipse is what? In coordinate geometry, you all know that ellipse equation x square by a square plus y square by b square equal to 1, and from which you did it in higher secondary mathematics that eccentricity e or say epsilon is always less than 1 minus b square by a square. Okay, you did it in higher secondary mathematics. So here we assume, and there you also know that is L is semi-latus rectum and 2L is latus rectum, and that is equal to 4A. You all know. So similarly here we assume L equal to mk by L square. That is semi-latus rectum. Semi-latus rectum of conic. And here we assume the eccentricity 1 plus 2el square by mk square. Okay, so we arrived at the standard conic section equation, and L is known as mk by L square is semi-latus rectum of conic, and this is known as eccentricity of conic. Okay, eccentricity of conic. Okay, thus we arrive at the conic section equation. Now here you have to remember that few things, that for ellipse the equation is this, ellipse equation is this, and corresponding eccentricity is always less than 1. Okay, hyperbola, the the equation is this: x square by a square minus y square by b square equal to 1, and eccentricity is always greater than 1. You must have to remember. Okay. This for parabola, what will be the equation? That is y square equal to 4ax, or you can say also x square equal to 4ay, depending upon the axis. Here eccentricity is 1, and for circle you must have to remember that the equation is x square plus y square, this is equal to r square, eccentricity is 0. Okay, provided this is 0 point, obviously. Okay, center, if the center is 0 provided here the center must be 0 then the equation of the circle holds good. You must have to remember these things. Okay, and you will get in coordinate geometry higher secondary. So this is what up to today. Now in today's lecture I have discussed the first law, conic section equation, and first law, and there we see that we arrive at the conic section equation. Okay, in our next class I shall discuss about the energy of elliptical orbits, and there we will see that energy solely depends upon the major axis, and we also discuss second and third Kepler law. Okay, so this is what up to today. So if you don't subscribe my channel, then kindly subscribe it to get latest videos on physics. Okay, thank you.